Hello, and welcome to the ALCTS webinar on VIVO and the role of librarians, Part 2. I am Amanda Stone, a member of the ALCTS Continuing Education Committee. I will be your host for today's webinar. Our presenter today is Violetta Illich, the Head of Cataloging and Metadata Services at the Frank Melville Jr. Library, Stony Brook University. Violetta has experience in managing content creation and dissemination of print and digital resources, supporting scholars' online identity with research management systems, and providing support for faculty, students, and staff on scholarly communication issues. Violetta brings much expertise to today's topic, and we are fortunate to have her with us today. A few logistics for today's presentation. All attendees are muted to prevent background noise, and we do not have interactive chat capabilities. You may, however, comment on today's presentation using Twitter. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so if you have questions for Violetta, please type them into the question box on your screen. We will have time for Q&A after the presentation. This webinar is being recorded, and you'll receive an email with links to the recording and presentation slides shortly after the presentation concludes. And now, here's Violetta. There will be a slight delay as we change presenters.
Hi everyone, welcome to the second part of the VIVO and the role of librarians webinar. My name is Violetta Illich, and I'm currently the Head of Cataloging and Metadata Services at Stony Brook University Libraries. I started my library career at Texas A&M as a library specialist in cataloging department and ended up as a semantic technologies librarian in the Office of Scholarly Communications because of the initiative I started. And that initiative is VIVO. My initial idea was to create a VIVO instance which will provide unique, stable URIs for all researchers on campus to be used in name authority records. Those records would be entirely comprised of trustworthy data coming directly from campus data stores we own. After that, I was at Northwestern University, Feinberg School of Medicine for about 3 years, where I had a chance to work and lead many digital initiatives projects. I also had a chance to work on the VIVO project, led by the team at Center for Data Science and Informatics at Feinberg School of Medicine. I have been part of the VIVO community for many years now and have worked on many task forces, including the VIVO Ontology Improvement Task Force, which is currently active. So as a reminder, our goal for today is to provide you with a valuable guide to best practices in modeling RDF data by utilizing data integration tools. To do that, you will need a good understanding of the ontology. We'll also go over basics of SPARQL. Last time, during part 1, hopefully you got a better picture and a deeper understanding of the VIVO semantic web platform and how you can go about finding the right resources for a new VIVO implementation, including data sources, team members, governance models, and support structures. So that part was basically more into policies. Last time, if you remember, I shared this slide for those of you that were actually attending the part 1. I shared this slide in hope to give you an idea of how important data is, because with VIVO, you will create a coordinated faculty research information management strategy where lots of data is put together in a data hub or data warehouse. There are various campus stakeholders and or actually data owners that you need to work with to accomplish this goal. These internal data stewards, stakeholders, and or owners include the provost office, human resources, you as the library, the faculty itself, the registrar office if you plan to add the teaching activities, the IT, information security office, the office of research, and many others. So it's all about data. It really is. What data you have, how you manage it, how you model it, and how you display it. The data needs to be in perfect shape, and to make it as such, it's not easy. So VIVO talks about these things that you see on the screen. And this is the data that VIVO needs in order to demonstrate and showcase the scholarship and all the activities done on campus. We have publications, presentations, books, data sets, and they can be self-reported. People automatically populated into your VIVO from a trustworthy campus data source, usually the human resources system. You have locations which are included with the VIVO, and that includes only countries. Dates, you can generate a collection of dates for use in your VIVO instance. Journals, you can generate a collection of journals in a research description framework for use in VIVO. Like, for example, I did for the Open VIVO project, and that's actually an open source project, and you can go and fetch that data if you want. For that project, I generated a list of around 45,000 journals, and all of them had an ISSN. And we use those journals in Open VIVO platform. Then we have outside organizations, and you can generate a collection of organizations in RDF using the grid data that comes from digital science. And it's open actually, or it's open access, you can download that data. Or maybe some other sources if you like, you don't need to use that one. Then we have concepts. There are many control vocabularies available for use. And again, you can choose one depending on what is most appropriate for your institution. So how do we get data into VIVO? There are basically 3 ways. The user puts it manually if you allow them to log in and edit their profiles. You put it in manually. This is actually only doable for small size institutions. Or the software puts it in automatically. And that's what actually you are going to go for. So let's look at what we have and what our data is representing. As you can see, it is centered around researcher activities. The funding he or she gets, projects, papers, research areas, data sets, events they're attending, organizing, speaking at, and resources they have and use. To showcase all of this data in a semantic web application, we need an ontology to describe that data with. VIVO itself is an ontology-driven application because it uses an ontology as the basis for its semantic data model. The underlying technology is Vitro, a general-purpose, web-based ontology and instance editor with customizable public browsing. Vitro is a Java web application that runs in a Tomcat server container. With Vitro, you can create or load ontologies in all formats, edit instances and relationships, build public websites to display your data, and search your data with Apache Solr. This application is now, the Vitro, is used by the Link Data for Libraries folks. But back to VIVO. VIVO can change in response to adjustments in the underlying ontology it uses. With minimal reprogramming, VIVO successfully balances demands for data modeling with requirements for presentation and user interaction. So to summarize, VIVO is software a triple store for subject, predicate, object assertions, a web-based ontology editor, generic assertion management through Vitro, and scholarship assertion management and display through VIVO. And also, VIVO is data, assertions about scholars and their scholarly works. Just a reminder, what's an ontology? My favorite definition is by Tom Gruber. In the context of computer information sciences, an ontology defines a set of representational primitives with which to model a domain of knowledge or discourse. The representational primitives are typically classes or sets, attributes or properties, and relationships or relations among class members. The definitions of those representational primitives include information about their meaning and constraints on their logically consistent application. In the context of database systems, ontology can be viewed as a level of abstraction of data models analogous to hierarchical and relational models, but intended for modeling knowledge about individuals, their attributes, and their relationships to other individuals. This is you can look up this definition by Tom Gruber. It's a really nice short article. Relation to ontology. How VIVO relates to this. VIVO produces linked data, right? And because it's a semantic web application. In VIVO, everything has a URI, the unique resource identifier. The URI looks like a URL, but may or may not point to a resource over a network. As a reminder, in information technology, a uniform resource identifier is a string of characters used to identify a resource. A URL is simply a URI that happens to point to a resource over a network. It's important to keep in mind that data is described or modeled with the help of the VIVO ISF ontology. I mean the data used in VIVO. When systems use the VIVO ISF ontology, they basically speak the same language and data sharing becomes much simpler. VIVO has many classes from several different ontologies to represent scholarship. The classes and their ontologies are shown in this figure, which of course probably you can read, but you will get the slides and you can look it up, and this is also available on the VIVO DuraSpace wiki page. You may have additional classes as a result of local extensions, and I'll speak about that later. All classes delivered with VIVO should be included in the diagram. Classes in the respective ontologies, but not delivered in the VIVO application, are not included in here. For figures related to the ontologies on which VIVO is based, you can look up the corresponding ontology projects. So when we talk about this, it's important to understand. Remember the slide, things VIVO talks about. So those are actually the domains of representation. Boxes represent kinds of things that might be ingested, either manually or by API or in bulk. In the middle are the people. Above the people are the domains of the scholarly record. There are others, but these are recognizable for now. Below the people are entities that need to be in VIVO for cross-link work, but are not necessarily specific to the VIVO instance. I mentioned the many ontologies used in VIVO, and you can see there are many. And for each of those to explore them further, you can visit these links. We actually, if you want to understand the VIVO ISF ontology, we loaded it into Lodi and in a human understandable way, so you can navigate the ontology and understand the classes and properties much better. It really helps with learning the VIVO ontology. So you are ready to start writing statements or as they are called, triples. You will do that by using a subject, an entity, a predicate, which is an object property or a data property, and an object, any individual in Vivo, just like in a regular sentence, right? So basically what I'm saying here is Violetta Illich is the head of cataloging and metadata services. Looking at this example, we have two things, right? Thing 1 and thing 2. Thing 1 name is College of Science. Thing 1 is college. Thing 1 has part, which is thing 2, right? Thing 2 is a department. Thing 2 name is the Department of Chemistry. These statements are also called assertions. They are also called triples. So what I demonstrated in this figure, this is in words, in sentences. It's very important to draw diagrams when you work with ontology. It's much easier to understand what's going on. In the next few slides, I will show few ontological models represented as diagrams drawn using the open source tool VUE from Tufts University. These diagrams show the relationship between entities in Vivo. Diagrams from the primary entities of scholarship, such as people and publications, have diagrams centered on the primary entity. They focus on common attributes and relationships. They are not comprehensive. Additional attributes and relationships are available, of course. To check on this, please see the Vivo interface. If you have the Vivo installed already, you can use the Sparkle queries to determine what exactly is going on, and you can examine the ontology to discover additional attributes and relationships. So first we'll start with a person. A person has type, can be faculty, staff, graduate, student. These are more correctly modeled as roles, actually. A person has a vCard for contact information. vCard is one of the ontologies used in Vivo. Has various identifiers, Scopus, Researcher ID, ORCID, ERA Commons, and so on. Has a photo, home department, link to the home department page, research area, various concepts that come from a control vocabulary, whichever you choose. Is related to positions, education, and roles in grants, papers, courses, organizations, and other activities. The ontologies are sufficient to represent the relationships between the entities and properties of scholars and their works. So in a model, this is how the person model looks like. So just a note for future reference, the dark blue is the entity being modeled, right? That's the fourth person in this case. Light blue are entities dependent on the entity being modeled. These will typically be created along with the entity being modeled and should be removed if the entity being modeled is removed. So if you remove a person from your institution, Vivo, all of this will go. All of these other entities in light blue will go away. And the green is an independent entity. These typically pre-exist in your Vivo when adding the entity being modeled. These should not be removed if the entity being modeled is removed, because as you can see in this example, that's SCOS concept, and those are basically the research areas that you're going to map to the SCOS concept. And of course, they're not going to go away because there are many other people that are related to the same research area. So the person entity has a large collection of literal values. The most common are shown in the person entity below. People are associated with research areas represented by SCOS entities. Positions are relationships between a person and an organization. The organization model will be shown later, so you can see how that looks. The position may have an associated date-time interval. We'll see those models too. The ORCID of a person is represented as an entity. The URI of the entity is the ORCID of the person. The photo of a person is stored in a file, a reference using triples associated with the person. The vCards are used to store contact information, name parts, URLs, and geolocation. The general pattern is that the person has a vCard. The vCard has an intermediate related to the type of information to be stored, and the intermediate has references to literal values. And of course, additional details regarding the person can include teaching, grants, publication, advising, educational training, awards, membership, and all of those will show in the separate models. This is the organization model. Organizations in VIVO are entities with the RDF type FOF organization. VIVO Overview is used to provide a text description of the organization typically displayed on its profile page. A vCard is used to record contact information, URLs, and geolocation. You can see all of this in this model. Organization may have relationships to other organizations. The part of relationship describes an organization as part of another in a hierarchical sense. For example, the history department may be part of the College of Liberal Arts. The successor relationship describes an organization which no longer exists and for which a successor organization now exists. The affiliated organization describes an organization affiliated with the primary organization. Too many organizations mentioned in this sentence, but it's true. Everybody who has worked with in cataloging, especially with change of names of publishers or any other corporate body, can understand the complexity of this. The relationship is not symmetric, that is, the inverse is not inferred by the inferencer. Assert the reverse affiliation is needed. Many other attributes and relationships are available for organization. These are just the typical one in any VIVO implementation. This is, for example, the journal model. It looks very simple, right? In VIVO, that's an entity of type BIBO journal. It uses the BIBO ontology. The journal has a series of attributes. All are literals in this case. Journal entities are really quite simple. This is the publication model, which is very complex. And it's, as you can see, there are many relationships, and you can see how it relates to the person, to any individual, to the fourth person in this case via authorship relationship. And that's something that is important to remember when trying to model the data you get about publication and your people. The grant model, in this case, this grant entity has attributes to record funding amounts, label, abstract, local award ID, and this ID is assigned by the administering organization. Usually, if your Office of Research is nice, they can share that data with you. And sponsor award ID, this ID of the grant is assigned by the funding organization. So all of that information can be mapped and recorded. VIVO ontology accommodates all of this. The funding organization is related to the grant through VIVO assign and VIVO assign by. For additional details regarding model organizations, we should go back to the organizational model to see how we can connect the dots. So an organization, often an academic department, typically has a role in administering the grant, right? This is modeling using an admin role which associated the grant, the role, and the organization administering the grant. The grant may have one or more subject areas represented as cost concepts. One or more people will be associated with the grant through roles. There will be one role for each person. The roles associated with the person can be the PI role or the co-PI role and all that. We have the model for education and training. The entity of interest here is the awarded degree, the dark blue in the center of the figure here. The awarded degree is a relationship between a person and an academic degree. The academic degree can be considered abstract. The award degree is concrete. A person received the degree from a university at a particular time, right? VIVO provides a control vocabulary for academic degrees, and note that the label for the degree is on the academic degree. It also has an associated educational process, right? Because getting the degree was part of a long process. That process is the educational process, which contains attributes of this degree. And also, the educational process has daytime interval. So we also have model the advising relationship. If you want to add this information in your VIVO, it was super fun actually to do this when we were at Texas A&M. This was our grant that we got to get ORCIDs for all of our graduate students, and this was the modeling that I had to do for that particular grant. As you can see here, the advising relationship can optionally have three types. The following types: faculty mentoring relationship, graduate advising relationship, undergraduate advising relationship, postdoc or fellow advising relationship. And take note that these are all available from the VIVO ontology. The advisee role relates the advising relationship to the advisee. This pattern is common for modeling roles and relationships. And of course, this is optional, right? You don't need to include this information in your VIVO if you don't want to. And also, you can assign daytime intervals if you want. So let's see how the award model looks like. The entity of interest here is the award receipt. It's a relationship between a person and an award. The award entity is generic, as in the Nobel Prize in Physics, right? The award receipt is specific, as in person X was awarded the Nobel Prize in Physics by the Royal Swedish Academy of Sciences on 10th of October 2017. The fourth agent is the entity awarding the prize, the fourth agent here that you see on this diagram. Membership is represented by using a membership role to associate a person with an organization, like a committee or any other organization. The membership role is associated with the organization using the VIVO role contributes to and VIVO contributing role. So those are classes that do exist in the VIVO ontology. And of course, this is an optional label. You don't need to add this kind of information, but if you do, you have the option, the label to indicate whether the person is a chair of some committee or is a member of some task group, or however you want to express that. This is a complex diagram for the VIVO authorship, where you need to connect the article to the author. I have to admit that this was the most complex thing I had to model using the Karma data integration tool, and I'll show that a little bit later, but once you get it, it's really simple. This is the datetime value. The VIVO datetime value actually supports the concept of precision, which indicates whether a particular datetime value is accurate to the day, or perhaps only to the month, or maybe only to the year. Precision is an important idea. Publication dates, for example, are often known only to year precision and sometimes to year and month. The model indicates that creating a datetime value requires three triples. one to specify the type, one to specify the literal value of the date time, and one to indicate the precision, right, as you can see here. Then we have the date time interval. This is an entity that references one or two date time values. Either reference could be missing. An interval might have a start date and no end date, for example. And you can use this date time interval model to model the end and start and end date for your people hire. For example, postdocs that are coming or visiting faculty, if you want to include them, you can use this model to add the precision of their time being at your institution. Of course, there are some issues that I want to mention about the VIVO ontology. Basically, VIVO occupies the middle ground in the ontology. It's more abstract than the BFO or the OBO Foundry, and it's less abstract than domain-specific ontologies and vocabularies, like some from the cultural heritage, for example. Most ontologies VIVO introduce their own middle concepts, and they must be reconciled with the VIVO ISF. The VIVO ISF ontology is actually facilitated by OpenRIF community, to which I'm a member of course. So now that we got all the data, we learn a little bit about ontology, we are ready to model that data. And I'm going to show how you can model the data using the Karma Data Integration Tool, developed and maintained by the Information Integration Group at the Information Science Institute at University of Southern California. As noted on their website, Karma is an information integration tool that enables users to quickly and easily integrate data from a variety of data sources. Users integrate information by modeling it according to an ontology of their choice, using a graphical user interface that basically automates much of the process. And it's very helpful, that interface. Karma learns to recognize the mapping of data to ontology classes and then uses the ontology to propose a model that ties together these classes. This is very actually important and helpful. Users then interact with the system to adjust the automatically generated model. During this process, users can transform the data as needed to normalize data expressed in different formats and to restructure it. Once the model is complete, users can publish the integrated data as RDF or store it in a database. This is, as I said, all available on their website to learn how to use Karma. So you need to accommodate within existing ontologies most of your data, right? And you need to examine your data, you need to clean your data. I can't stress enough how important this part is, this step is, the cleaning of your data. If you need to, you can create local ontology extensions. And I recommend this only and only if you want to accommodate the local IDs that you have in your institution. For example, local IDs for your people. You may have various, like some schools have barcodes, have net IDs, have university ID, and many other. And there is no enough space in the current ontology to accommodate those. So you need to create those for yourself. And I have created those, so it's easy for you to use and get that from my GitHub, and just change the namespace I've used to the one that you want to use in your own instance. Karma can integrate data from a variety of data sources, including databases, spreadsheets, delimited text files, XML, JSON, KML, and web APIs, and that's very important. First step involves mapping of each column of a source, if you are talking about a CSV file, to a node in the ontology. In the beginning, you will be training the Karma tool to learn the semantic types you want to assign to your various data fields. After that, the previously learned semantic types are easily recognized by the tool, and the work gets really much simpler. If the offered semantic type is incorrect, the user can select from the menu the correct node in the graph ontology. Second step involves defining the space of all possible mappings between the source and the ontology. At a high level, the nodes in the graph represent classes in the ontology, and the edges represent properties that relate these classes. Third step allows for updating the graph to refine the model based on user input. Fourth step allows for generating a source model that can be safe for future use and apply to data sources that user wishes to model to the same semantic types. So you can import data directly from databases. This is the menu you get, using SQL, directly from a service, or from files such as CSV. So this is an example of a CSV data, in this case for organizations. As you can see, there are two values, name of the department and the department ID, that you hopefully get from some of the data sources on campus. Or if you don't get it, then you assign one for each department and you keep that information safe, and you make sure you know which ID you assign to each department for the next time you load data, right? The third column is the URI you assign using the Karma tool. In this slide, you see that the columns are now modeled using the VIVO ISF ontology. And it's modeled based on the organization model I showed earlier. Basically, the RDFS label is used to say that this is an academic department. And org ID, what you see here, is from a local ontology extension I created because I really wanted to use that org ID as a unique identifier for the organization, for that specific department, for all of the departments actually. And I use that org ID to append it to the URI and create a unique URI for that organization, for that department, that's going to be used over and over again in the VIVO instance. So it's important to understand what's happening here. Like in the previous slide, you're modeling and you're created. So something's happening in the background, right? In Karma. What's happening is that you can save the model that you saw on the previous slide. You can save that model and it can reapply it in the next data set with department names that comes your way, right? Because who knows, department can change name, or the next time you get new people coming from that department, you're going to get that information together, right? This person is now a faculty member at the chemistry department. So you're going to get that same department. And you're going to have to model that data again. But you don't really have to model because you saved it the first time you modeled it, because Karma enables you to do that. This is called R2RML, a language for expressing customized mappings from relational databases to RDF datasets. The good thing is that you don't write it yourself. It's done by Karma in the back end, but you can save it and reapply it. The R2RML mappings are themselves actually RDF graphs written in Turtle syntax. R2RML enables different types of mapping implementations. Processors could, for example, offer a virtual Sparkle endpoint over the map relational data, or generate RDF dumps, or offer some kind of a link data interface. Once you model your organizational data, and let's say you save this R2RML model to save it for next time, you can also publish that RDF, those triples. In this case, what you see here, what happened after I modeled those organizations from slides before, this is the end result. After I'm done modeling, I click Publish RDF, and this is what I get. I get the triples, all the statements about this department, about all of these departments, right? As you see on the screen. And this is the person file. This is how you model the complex person file that comes your way, right? So, of course, you're not going to be able to see it here, but once you get the slides, you can zoom in and see what exactly is happening. And you model it with the help of the VIVO ISF ontology. You can save the model and reapply it to the next batch of person files you receive, right? The power of R2RML is extraordinary because you sweat it only once and then you just work with the same model over and over. You do have to make sure that in order for this R2RML to work, that your CSV data is impeccable and the column names are the same if you want to successfully reapply the same model. Otherwise, the Karma is very smart. It's going to tell you no such data found, and it's going to prompt you to apply semantic types. And it's going to be easy for you to fix it, but if it's very important to have a consistent naming schema. Even capitalization is important in how you capitalize the names of the columns. So this is how the person and triple file looks like. This is all we know about this professor. This is actually a sample file. It's not really a real person. I use this for the VIVO camp, which, by the way, is happening at the University of California, San Diego from 5th through 7th of April. There is still room if you want to sign up for a 2.5-day training. And we have his start date, we have his name, his title, his department affiliation, and all that information. Simple information. Once you have the organizations and people model, because that's how you start. First, you model the organization, then you model the people, then you're ready to model their positions within the organizations. And this is how that model looks like. So you get only the university ID, the unique identifier for that person. You get the job title, you get the position type, you get the organization name and the URI, right? And then Karma interface allows you to pick and assign correct semantic types using the VIVO ISF ontology that you learn by looking at the models that we looked before and trying to understand that ontology and all of the relationships between classes and various properties. And just for show, this is also another complex modeling of publication data, academic articles. This is basically actually, but like I said, you model it only once and you just reapply the same model for the next round of publications that come your way, regardless of where they come. So you may have few different models. Let's say you have coming straight from your symplectic elements implementation, or you have from PubMed, or you have from Crossref, or from unpaywall data, that you filter for only your researchers. There are various ways to get this data and to model it, but this is basically the way that you model, and you can feel free to zoom in and see how all of this looks like. So now that you model and produce the RDF data and loaded it into your VIVO instance, you can run all sorts of Sparkle queries to produce reports for different stakeholders on campus, right? Sparkle is so powerful and can give you instant information just by running and asking simple questions. So just to remember, all things in VIVO have a URI. In VIVO, the URI usually looks like this. For example, my URI in OpenVivo looks like that. We use the ORCID ID to create the URI. And why do we want to use the VIVO data? We can make various lists, we can count things, we can make many reports, various reports starting from very easy to very, very complex reports, and we can get the data out of VIVO for use in, either Excel or any other statistic software. I've done it with SAS, for example, R. You can use it with reporting software like Crystal Reports, or you can load it into visualization software like R and produce amazing graphs that, of course, any administrator on campus loves to look at. So Sparkle is a query language for asking for data from a set of triples, and it's so easy and fun. And you will be able to write these Sparkle queries because you will already know the VIVO ontology, you'll know which classes you have, you'll know which properties you have, and you can ask these questions very easily. With Sparkle query, we want to list the predicates and objects of all triples for a specific subject. For example, this is a very, very easy sample query I run on the OpenVivo. It's basically for me, and it's giving me the list of the predicates, and I'm asking for all the list to list the predicates and objects of all triples, right? For this specific object. And this is the results. This is how I get the results. You can see how I got the results. And this is just the simplest way to get data out. And this is done literally in 1 second. But some complex Sparkle queries can take a while. And that's why sometimes you want to add some limit. Like, let's say 100 or 500, if you want to test, for example, what kind of data you have in VIVO and how you can get it out to VIVO with Sparkle queries, you can, I recommend you really limit that. And the sample Sparkle queries, there is this link on GitHub created, Mike Conlon, the VIVO project director has shared some of his Sparkle queries, and they range from easy, medium to very complex, and you can modify them and run them with you. They are tested with VIVO 1.9. They even work with the OpenVivo. If you learn how to recognize which classes exist or don't exist in the OpenVivo. For example, the University of Florida ontology, local ontology doesn't exist in OpenVivo, so I won't be able, or you won't be able to run any of those queries that have the predicate of the University of Florida local ontology. I can't stress enough how important it is to first learn to get your data, to clean your data, to model the data, to understand the ontology base, right, to be able to model the data, and that learn how to get that data out, produce all sorts of visualization reports, and showcase that amazing scholarship that's happening on your campus. So that's it for today. Again, acknowledgements like last time in alphabetical order. I am really grateful for all I have learned from Paul Albert, Jim Blake, Mike Conlon, John Corson Reichert, John Ferreira, Huda Khan, Muhammad Javed, Julia Trimmer, and many, many others in the VIVO community. Thank you so much.
Thank you, Violetta. This has been a really interesting session. I learned a lot, not just about VIVO, but about a lot of the tools that you use surrounding it and how to manipulate the data. Can you talk for just a second about the view from Tufts that you use to do some of the some of the graphs? I really liked that tool.
Mm-hmm. And you can use that tool. I think a majority of ontologists are using that tool to draw the diagrams to showcase the model, so it's clear. It becomes clear to people what exactly is happening here and how exactly they should be going about to express the relationship between the various entities. It's an open source tool. It's very easy to install. They have various documentations. There are, that can help you learn how to do that. And I really recommend it, not just for ontology, but for any other, visualization activities that you may need.
Great. And if anyone in the audience has questions, please type them into the question box if you've not done so. And I'll let Violetta know. I thought it was interesting that you mentioned information security as a partner. Hadn't thought about making sure that your data that you ingest from other organizations, making sure the security sort of comes along with it.
Oh yes, yes. You have to be careful with everything, with everybody on campus. This is a complex project, as you can see and you can imagine. Not one unit on campus can do it by themselves. It's a group project, and it doesn't matter who's the initial initiator or who's the person or the entity on campus leading the project. Either that be the library or the provost office or the office of research. All those entities will end up working together. If it comes from the provost office, they will need the data coming from the library, right? So all of this, all of these various entities do work in unison. They share the data, and it's important for you to understand that the IT, the office on campus, the central IT, will be very interested in making sure your application is run safely and securely.
Great. We did have a question from the audience. Can you talk a bit about the benefits of VIVO's complex ontology?
The benefits, many benefits. For example, as you can see, I just touch on very few models, right? And I just touch on just few of the relationship that can be expressed within those models. You can basically describe anything with the VIVO ISF ontology. And if something is missing, for example, like right now we are working on the VIVO ontology improvement task force. We are working on deciding what else we are missing in the ontology and what is basically not needed anymore. So we will possibly delete some of the entities, but we'll also add additional ones. Like, for example, classes that will help us describe digital humanities and social sciences scholarship that's happening on campus. Because as you may remember, I mentioned that in the first webinar that VIVO started in the life sciences. So the ontology didn't have many of the relevant classes to express the scholarship that was happening in these areas, very important areas on our campuses, humanities, social sciences, and all that. So Duke University has done amazing work in extending that ontology to accommodate for these particular scholarly works, and they will eventually end up in the VIVO ontology. So I like it that it's complex because you can literally explain and express everything and then display it in the VIVO application for everybody to see.
Great. Do you have any advice for institutions where departments and their hierarchy change frequently, as we know they do?
Hierarchies are complex. So we actually had a very complex case at Northwestern at the Feinberg School of Medicine. You know, changing of the names, where how everybody is related to each other. Are they really related or are they not related? Is Northwestern Medicine or all the centers that are surrounding the Northwestern Medicine, are they really part? So you really have to basically sometimes break some of the relationships, how you express them, and then assign the new relationship. And you can do that basically even from the VIVO interface, from the admin side, whoever is the metadata librarian or the cataloger or whoever ends up working on this part. And I really truly believe that the metadata cataloging librarians are the best people to work on this ontology related and data modeling business, along with the software application developers from the library IT. So you can easily reassign and a different relationship with a different entity and break the one that doesn't exist anymore.
Yeah. And we have time for one more quick question. What challenges or lessons learned can you share about pulling data from library systems such as institutional repositories?
Oh, from institutional repositories, I think that's I would guess that's I think, in my opinion, that's the easiest thing to do, because you own the repository, you are the project owner, you know what's going on, and then like if you go and look at the scholars at Duke, or even my former place of employment, scholars at Texas A&M, you can see how they have, and many other actually, how they have integrated their articles. And if there is a link to the either an article or a presentation in the institutional repository, that link is literally its display on the profile page of that faculty member that you're looking at the VIVO instance. So it's very simple to show that you have provided links back to either your library databases or to your institutional repository or to some other open source disciplinary repository like Archive or Open Science Framework and all that. And more people are looking into doing more work with that.
Great. Just wanted to let everyone know that we are glad you could be with us today. You will soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and they help the ALCTS Continuing Education Committee plan future events. The email will also include the link to today's slides and recording. You now have the opportunity to receive a certificate of attendance, and that information will also be in the email. I'd like to thank our presenter, Violetta Illick, and thanks also to members of the Continuing Education Committee, Felicity Dykes and Joseph Nicholson. And thanks to Jasley Coley from the ALCTS office. The support they provide makes it possible for us to present these webinars. ALCTS also has other continuing education opportunities coming up. We have several more webinars this spring, including a webinar series from MARC to BibFrame, linked data on the ground through May 2nd. See the ALCTS website to register or find out more information on these events. ALCTS also offers web courses, which are 4 to 6 weeks long, as well as 2-day email discussions. Our next e-forum will be on March 20th about cataloging and metadata education. Check the website for information on upcoming courses and discussions. Thank you all for joining us today, and this concludes our session.